Hello everyone. In this video, I will solve another problem from the Philippine Mathematical Olympiad. In the figure below, 5 circles are tangent to line L. Each circle is externally tangent to two other circles. Suppose that circles A and B have radii of 4 and 225 respectively, and that C1, C2, and C3 are congruent circles. Find their common radius. Whenever I encounter a problem of this type, I usually connect the centers of the circles or draw some segments starting from the centers perpendicular to the given tangent line. Now, I will start by dropping segments from the centers of circle A and B perpendicular to the tangent line L. So we have this segment, and this is 90 degrees. We also have this segment, and this is likewise 90 degrees. I will also draw a segment passing through the centers of C1, C2, and C3 perpendicular to the radii of circles A and B. So this is 90. This is also 90. I'll form right triangles by connecting these points. Okay, and these points. Now we can also create another right triangle by connecting the centers of circles A and B, and then drawing a segment starting from the center of circle A perpendicular to the radius of circle B. Okay, now let us label some points. So let's say this is A, B, C, D, and E. We also know that the radii are 4 and 225. Okay, so this one right here is 225, the radius of the green circle. This one is 4, the radius of the blue circle. We also know this is 4. That's another radius. This one right here is another radius of circle B. So this is 225. Now let us represent the radius of C1, C2, and C3 by R. Okay, so this one right here is R. This one is also R. Now, automatically this is R. Similarly, this is R. So we can represent AE by 4 minus R. Because the radius is 4 and this right here is 4, is R I mean. So AE is 4 minus R. Similarly, BD can be represented by 225 minus R. Now, how can we represent BC? BC is just the difference between the radius of circle B and the radius of circle A. So that's just 225 minus 4 or 221. Okay. Now, let us find congruent parts in the figure so that we'll be able to create an equation. Observe that we have a rectangle, okay? The rectangle ACDE. And we know that in a rectangle, opposite sides are congruent. So we have ED equals AC. Now let us find expressions for ED and AC. Now if we focus first on ED, we can find an expression for ED by applying the Pythagorean theorem to this triangle, repeating the process to this triangle. We also apply the Pythagorean theorem to find the bases, and then we add those bases to this segment. Okay, now If we do that, ED is just equal to the square root of the square of 4 plus r squared minus 4 minus r squared. Okay? Plus this segment right here. That's just r plus r plus r plus r, or 4r, plus the base of this triangle, square root of 225 plus r squared minus 225 minus r squared. Now if we simplify this, we get the square root of 16r plus 4r plus 900r, square root of 900r. If we simplify further, this is just 4 square root of r plus 4r plus 30 square root of r, which is equal to 34 square root of r plus 4r. For now, let us set this aside and let's find an expression or the value of AC. Take note, we can also apply the Pythagorean theorem to right triangle ACB to find AC. Okay, so let's do that. AC is just equal to the square root of AB squared. AB is 229. So that's 229 squared minus the square of BC. That's just 221 squared. If we simplify this, we get the square root of 3600. And that is just 60. Now we will equate 60 to the expression 34 square root of r plus 4r, because as what I have said before, ED is equal to AC. So we have 34 square root of r plus 4r equals 60. Observe that we can further simplify this equation before we do something else. We can divide both sides by 2. So we have 17 square root of r plus 2 times r equals 30. Now let's gather all terms in the left hand side, and let's have 2r plus 17 square root of r minus 30 equals 0. Now take note that we can write r as the square root of r, and then we have plus 17 square root of r minus 30 equals 0. Okay, so we have now an equation that is a quadratic equation in square root of r, right? So we can actually factor this and solve for r. Now some may isolate the term with square root of r in this equation and square both sides to solve. Okay, but what I'll do now is factor this last equation. Okay, that is much easier. So I'll have 2 square root of r minus 3 times square root of r plus 10. So this implies that 2 square root of r minus 3 equals 0, or square root of r plus 10 equals 0. Now this case right here implies that square root of r equals negative 10, which has no real solution, so we don't take that case. Now let's have the other one. We have 2 square root of r equals 3. And if we divide both sides by 2, we get square root of r equals 3 halves. Now, let's square both sides. And finally, we get r equals 9 over 4. This is now the common radius of C1, C2, and C3. Okay, 9 over 4 units.